Now we will talk about the derivative of log functions. Okay. So before we get to the derivative, maybe let us review some of the properties about log. Okay. And one thing that we know, log and exponential, they are equivalent. Okay. So what does this mean? Is that if we have exponential functions or equation like a to the y equal to x, we could rewrite this into the log form, which is log base a of x equal to y. Okay. The a is the base of the the power that we have, and then y will be the exponents. Okay. X is actually the result of a to the y, so we will have log base a of x equal to the power, the exponent that we have. Okay. So for example, if we have 2 to the 3, we know that 2 to the power of 3 is equal to 8. If I rewrite this into the log equation, then I could write it as log base 2 of 8 is equal to 3 then. Okay. So of course, if I have log base 3 of 81 equal to 4, in other words, I could write that as 3 to the 4 power is equal to 81. Okay. Because of, again, exponential and log, they are equivalent. So therefore, we could actually, using kind of like exponential to help us to write some of the properties of log. For example, we know that a to the power of 0 is equal to 1. So then in this case, meaning log base a of 1 must be equal to 0 then. Okay. And the next one is a to the power of 1 is equal to a. And of course, to this one, a to the power of x is equal to a to the x. Okay. So this property right here is telling me that if these two numbers, they're the same, then the exponents is my answer. Okay. Now the last one is a really tricky one. I have a raised to the power of log base a of x is equal to x. Okay. So how do we get this property right here? Is actually we get it from the equivalent statement. Okay. Now again, if I have a to the y equal to x, for y then log base a of x equal to y. Okay. Now in this case, these two y, they're the same thing. So if y equal to log base a of x, then I could write as a log base a of x is equal to x then. Okay. So therefore, again, the last property, number 4, is get from the statement then. Okay. And then, of course, you also know that we have the 3 laws. So if we have log base a of x times y, then we will be able to rewrite this into the sum of 2 logs, log base a of x plus log base a of y. Log base a of x over y, we could rewrite into the difference of 2 logs, log base a of x minus log base a of y. Okay. And then the last one, this one right here is really useful that we use it a lot in this chapter here. Okay, is log base a of x to the power of c. It is equal to c times log base a of x then. Okay, we could actually bring the power, okay, to make it become multiplications. Okay, okay. Now, a couple mistake that I have some of the student made. Okay, so you have to be kind of like be careful about this. For example, like I have some student when they see log base a of x times log base a of y, they rewrite this into the sum of 2 logs. Okay, now remember you cannot do this. Okay, is log base a of x times y, not the multiplication of 2 log. Okay, or sometimes I have seen some student they do this. Okay. Oh, they feel that, wow, if I have log basis of x divided by log basis of y, then these two, they cancel. So my answer would be x over y. Again, this is actually the common mistake. Try not to do this, okay? We only have these three laws to work with. Okay, so then now, of course, usually we would like, that's when on our calculator, we see the log of x or natural log of x, ln of x, okay? What they are. Basically, the log of x is what we call the common log. Is the base is 10. And then for the natural log, the ln of x, the natural log, the base is e, okay? So because of this special property, so when you see log of 1, it is equal to 0. We just work with the property here. Then log of 10 is 1, log of 10 to the x is x. 10 raised to the power of log log of x is x, okay? And then we work with the three laws. Same thing with the natural log. Natural log of 1 is 0. Natural log of e is 1. Natural log of e to the x is x. E to the natural log of x is x. So this one is the one that we use a couple times already. Okay. And again, we have the three laws here. Okay. So we could rewrite again from the multiplication of x times y of log, natural log, right? We could rewrite into the sum of two log. Okay. Now those are the three property that again we are using a lot in this section. Okay. Okay. Then now let's look at number 3. Now number 3 is something that we will use it in this section right here. Is we would like to use the law of log to rewrite the expressions that we have in the form with no log of a product, quotients, and power. Okay. Okay. Then how do we actually do this? Okay. That means we don't want to have this x times y or x over y or x to the power of c. We would like to convert or maybe rewrite this into the sum or the difference or a constant multiple, something like this. Okay. Okay, so let's see how we work it out the problem. So to this one here, then what I could do first, I could actually rewrite this into natural log of 3x squared e to the x raised to the power of 1 over 3, right? Because this is a cube, okay, of 3x squared e to the x. Then now, we could use the law number 8 or number 8 property right here to rewrite this into 1/3 natural log of 3x squared e to the x, okay? Then now, because this is multiplication right here, so what we can do, we could actually using the number 6 here to rewrite this into the sum. So I will have 1 over 3 multiplied to natural log of 3 plus natural log of x squared plus natural log of e to the x. Okay, we could do that. And then now, natural log of 3, we cannot do anything. But natural log of x squared is number 8 again. Huh? So we could bring down the 2. So we write this into 2 times natural log of x. And then plus natural log of e to the x. Natural log of e to the x is x. Okay. Or you could look at this. Maybe we could bring the power down to make it become natural log of e. Okay. But one thing we know that natural log of e is 1, right? So then now the last step is I would like to distribute the 1/3 to the 3 terms. So I will have natural log of 3 over 3 plus 2 natural log of x over 3 plus x over 3. Okay. So then this is kind of like the idea that we have. Okay. Okay, so then now let us look at the next example now. Okay, so to this one here, then I would like to again rewrite this, okay, to the form that with no log of product, quotients, and power. Okay. Then my first step, I would like to rewrite this into the difference of two logs. Okay, log of 3a squared minus log of b to the 4. Okay, square root of c, I would like to rewrite this into c to the 1/2 power. Okay. Then now I will have log of 3 plus log of a squared minus, this one would be log of b to the 4th plus log of c to the 1/2. Okay. And now log of 3 plus 2 times log of a minus 4 times log of b minus 1/2 log of c. Again, why this is minus? Because of this negative, right? Okay, so then now we have again we talk about the derivative of log now. Okay, so then let's see how do we actually show that the derivative of log base b of x is equal to 1 over x natural log of b. Okay. I need to check my handouts now. Okay. Okay. Then now let's see how we work it out this problem. Okay. So my first step is really like what we did with the inverse functions. Okay. Because again, log and the exponential, they have the inverse relationship. Okay. So then the first step is I would like to let y equal to log base b of x. Okay. Then now, of course, we could rewrite this into b to the y equal to x. Then we take the derivative with respect to x to both sides of the equations. And then the derivative of b to the y is b to the y natural log of b and then y prime equal to 1. And I solve for y prime, I have 1 over b to the y natural log of b. Okay. And we know that again b to the y equal to x. So it will be 1 over x times natural log of b. Okay. So this one shows that the derivative of log base b of x is equal to 1 over x natural log of b. Okay. Okay, so then it's turned out that we have some special case. Okay. If we take the derivative of natural log of x, then it's equal to 1 over x. Again, if I take the derivative of natural log of x, okay, and remember natural log of x basically it will be log base e of x, right? Then in this case, we know that it is 1 over x times natural log of e. And we know that natural log of e is 1. Okay. So therefore, in this case right here, the answer basically is 1 over x then, right? Okay. So in this case, you will see that to the natural log, the graph of the natural log of x, okay? In this case, meaning this xy here must be positive, okay? Then now, if I take the derivative of natural log of absolute of x, then again, this is also equal to 1 over x. But in this case right here, we have x is not equal to 0 then, okay? Because the domain of this right here, it will be all real numbers except x equal to 0, okay? So in general, then if I take the derivative of natural log of u, it will be 1 over u du dx, or most of the time, we would like to write down as u prime over u then. Or just like what we did here. If I take the derivative of natural log of g, then it will be g prime over g, right? And if I have take the derivative of log base b of u, it will be 1 over u natural log of b and u prime, okay? Because again, u is a function of x, right? Okay. Then now, let's see how to actually take care of the derivative of log now, okay? So in this case, of course, we could actually use the idea that this one right here basically is the u, okay? So if this is the case, then if I want to work with the g prime of x, okay, then it will be 1 over u x times 5 to the x natural log of 5, okay, and we need to multiply to u prime, right? So which is we need to take the derivative of x times 5 to the x, the inner functions, okay? Okay, then now, if you remember that we need to apply the product rule here, okay? So then I will have 1 over x times 5 to the x natural log of 5, okay? And now I'm going to take the derivative. So I will have the derivative of x times 5 to the x plus x times the derivative of 5 to the x then. Okay. And then the derivative of x is 5 to the x is 1. So I have 5 to the x left. And then to this one, I will have x times 5 to the x times natural log of 5. Again, if you remember that the derivative of a to the x is a to the x natural log of a, right? Okay. Then now, let's see if we can simplify the expressions, okay? So I will have 5 to the x divided by x times 5 to the x natural log of 5 plus x times 5 to the x natural log of 5 divided by x times 5 to the x natural log of 5. Then, of course, to this one, you will see that these two, they cancel out, and then this one and this one cancel. So then I will have 1 over x times natural log of 5 plus 1, okay? Now to me, I have another way to work it out this problem, okay? Now this way right here, we just strictly using the rule to help us to finish the problem. But one thing about this is, do you see that in this case right here, we have log base 5 of x times 5 to the x. So in this case, can I use the property to take care of this problem first? Okay. Okay, so the property that I'm talking about is this one here. Okay. Let us try to rewrite again the log, okay, without any product, quotient, or power. Okay, so let's see. So again, I start with g of x is equal to log base 5 of x times 5 to the x. Okay, then it will be log base 5 of x plus log base 5 of 5 to the x. Okay. And remember, if this one and this one, they're the same, then I will have x, right? Okay. Then this is my g of x. Okay. Now remember, I haven't started doing the derivative yet. Okay. I just rewrite. Okay. And then now I'm going to take the derivative. Okay. Then in this case, log base 5 of x is 1 over x times natural log of 5 plus the derivative of x is 1. Well, we are done. Now, this example is actually give us a hint that if we have, again, log of any function that have like power, product, or quotient, right? What is the best way to take the derivative of this type of functions? We could actually using the law, the 3 laws, to help us to rewrite, okay, the expression without any, again, product, quotient, or power, right? Before we take the derivative. Okay, so now then let us look at the next example now. Okay. Okay, so to this example, again, first, what I would like to do, I would like to rewrite natural log of x squared to 2 times natural log of x over x squared. Okay. Okay, so I cannot simplify it anymore. So then now I'm going to take the derivative. So now we have a quotient, so we need to apply the quotient rule. F over g prime, right, is f prime g minus f g prime over g squared. Okay, so we are going to do this. So I have a constant, I take it out first. Then I would like to take the derivative of natural log of x times x squared minus natural log of x times the derivative of x squared over x squared to the square. Okay. And now the derivative of natural log of x is 1 over x times x squared minus natural log of x times 2x over x to the power 4. Okay. Then x and 1x cancel, so I will have x minus 2x natural log of x over x to the power 4. We could take out 1x, so I have 1 minus 2 natural log of x. Okay, and then this whole thing over x to the power 4. And now this x and this cancel. So my answer will be 2 times 1 minus 2 natural log of x divided by x to the power 3. Okay. Okay, so now let's see. Okay. Wow. I asked you to take the derivative of this function y right here. Okay. Now you will see that if I strictly doing the derivative, what happened? I need to, again, you have to think about this. So first I have to use a quotient rule. And then after I use the quotient rule, then here I have a product. So I need to use a product rule and then plus the chain rule, right? So it's actually involve a lot of technique that we are going to work it out this problem. So is there a way to simplify the process, okay? To make the problem is a little bit easier to help us to find the derivative y prime, okay? Or to the situation like this one right here. Now we have a function f of x raised to the power of another function g of x. Okay. Now remember, we do not have any rule to take the derivative of these directly. Okay. Because the rule so far, we have what? We have x raised to the power of n, meaning we are using a power rule is x is a function, but n is a number. Okay. So we know how to take care of this one. Another one is we have a number raised to the power by functions like exponential. Okay. But again, this one is a number, right? This is also a number. So once we have a function raised to the power of function, then we have no rule to actually take care of this type of problem. Okay. Then how do we actually work it out this then? Okay. Fortunately, we have a technique is what we call logarithmic differentiations. Okay. So then in this case, we can use the log differentiation to differentiate some complicated functions involve product, quotients, and power, or power then, just like the case that we have A right here. Okay. Then how do we actually work it out the problem? First, we would like to take the natural log to both sides of the equation of y equal to f of x. So the idea is kind of like this. Now I have y equal to f of x. Then now I would like to take the natural log to both sides of the equations. Okay. Then now we would like to differentiate implicitly with respect to x. Then now we would like to take the derivative, okay, to both sides of the equations. Okay. And then now remember the derivative of natural log y. Okay. It's just like what we have here. Okay. The derivative of natural log u is u prime over u. So if I imply this, so I have the derivative of natural log of y, okay, then it will be y prime over y then, okay. Then to this side, we'll have y prime over y. And then to this right here, because we take the natural log. So therefore, if we have a product quotients power, we could rewrite this into the sum, okay, or the difference of log then without any power. And then after we have this, then what we need to do is, the last step is we would like to solve for y prime. So basically to this one here, then we will move the y prime is equal to, move this to the side, y times the derivative of the natural log of f of x then, okay? So this is kind of like the idea about how we use the logarithmic differentiation to take care of some functions that is really complicated, okay? Now remember this technique right here will not work if we have addition and subtractions. So unfortunately, it's not working. Only work with to simplify the process to work with the product quotient and the power. And also notice the expression that I have, okay, is not taking the derivative of natural log. Okay. Okay, and then after we find the y prime, then we would like to evaluate, okay, to work it out when x equal to 1, then what is the y prime equal to? Okay, so this is what we want to do. Okay, so then let's see how do we actually start with this problem now. Okay, so therefore, when we work with this problem, then what is my first step? Okay. First, we would like to take the natural log to both sides of the equations. Okay. And now we are going to rewrite, okay, the right-hand side. Natural log of square root of x plus natural log of e to the x squared minus x and minus natural log of x plus 1 raised to the power of 2/3, right? And then now I could rewrite again, square root of x is 1 to x to 1/2. So I have 1/2 natural log of x plus x squared minus x, okay, multiplied to natural log of e, which is 1, and minus 2/3 natural log of x plus 1. Okay. Maybe you could consider that this step right here is your step 2. Is actually is rewrite the natural log of y into addition and subtraction of log without any power. Okay. Okay. Then now, step 3 is we would like to take the derivative with respect to x to both sides of the equation now. Okay. Okay. And now, of course, we are taking the derivative now. Okay. So in this case, I will have y prime over y is equal to 1/2 the derivative of natural log of x is 1/x plus 2x minus 1 minus 2/3. Again, the derivative of natural log of x plus 1 divided by x plus 1. Okay. And now I will have y prime is equal to y times 1/2x plus 2x minus 1 minus 2 over, again, the derivative of x plus 1 is 1, 3 times x plus 1. Okay. Then now I would like to replace y with square root of x e to the x squared minus x divided by x plus 1 raised to the power of 2/3, then multiply to 1/2x plus 2x minus 1 minus 2/3 times x plus 1 then. Okay, so then this is the derivative that I have. Okay, and now what I need to do, okay, I need to evaluate the y prime at x equal to 1 now. So it is equal to square root of 1 e to the 1 squared minus 1 over 1 plus 1 raised to the power of 2/3. 1 over 2 plus 2 times 1 minus 1 minus 3 over 2 over 3 times 1 plus 1. Okay. And then we know that square 1 is 1. E to the power of 0 is 1. So I have 1 over 2 raised to the power of 2/3. And then here, I will have 1/2. 2 minus 1 is 1. And minus 2 and 2 cancel 1/3. Okay. And now, of course, to this one here, then I could multiply this by 3, this by 6, this by 2, right? To work with the LCD, which is 6 then. So I have 1 over 2 raised to the power of 2/3. Then here I have 3 plus 6 minus 2 all over 6. And now I will have 7 over 6 times 2 to the 2/3. Okay. This is my answer then. Okay. And now let's see how we actually take care of the derivative of x raised to the power of cosine of x now. Okay. So if we have, okay, if we take the derivative of a function raised to the power of functions, in this case, we must use logarithmic differentiations. Okay, to finish this problem. No other choices. Okay. Okay, so then now I need to take the natural log to both sides of the equations. Then, of course, to this one, I can bring the cosine of x down to make it become cosine of x times natural log of x. Okay. Then now we differentiate. We take the derivative to both sides of the equations. Okay. Then, of course, to this side, we have to use a product rule. So the left side, I have y prime over y is we take the derivative of cosine of x times natural log of x plus cosine of x times the derivative of natural log of x. And I will have y prime is y times the derivative of cosine of x is negative sine of x, natural log of x, plus cosine of x. The derivative of natural log of x is 1 over x. Okay. So I have y prime equal to y is x cosine of x. Maybe we could have cosine of x over x minus sine of x natural log of x. Okay. Okay, so then now I would like to evaluate. So I would like to evaluate y prime at x equal to pi over 2. So which is equal to pi over 2 raised to the power of cosine of pi over 2. Cosine of pi over 2 divided by pi over 2 minus sine of pi over 2 natural log of pi over 2. Okay, this is what we have. Okay, and then we know that in this case, cosine of pi over 2 is equal to 0. Okay, that means I have pi over 2 raised to the power of 0. 0 divided by pi over 2 minus sine of pi over 2 is 1 times natural log of pi over 2. Okay. Then we have 1 times 0 minus natural log of pi over 2. Okay. And my answer will be negative natural log of pi over 2. Then. Okay. Okay, so then let us work on our last example. Okay. Okay, so again, this problem right here, I would like to determine whether the graph of y equal to x times square root of x has any horizontal tangent line. Okay, so again, when I see this, I know that we are going to work with the y prime equal to 0 now, right? Okay. Then now, let us look at this problem first, okay? Y equal to x times square root of x. Let us look at these functions. Now, what is the domain of this function right here? Okay, maybe let us try to see. Now, first of all, if we look at x right here, then to this x, it could be any numbers. But the square root of x, again, the domain of the square root of x, okay, the domain is actually, it will be from 0 to infinity, okay, because again, the graph of the square root of x is here, okay. However, if x equal to 0, then I have 0 raised to the power of 0, which is undefined. So therefore, the domain of this function y, it will be from 0 to infinity then. Okay. Right. Okay. Then now, let's see how we find the y prime now. Okay. So then we will take the natural log to both sides of the equations. Okay. Then I will have natural log of y equal to square root of x, natural log of x then. Or maybe I rewrite this into x to the 1/2 times natural log of x. Okay, it's easier for me to take the derivative. Then now I would like to take the derivative with respect to x to both sides of the equations. Okay. Okay. Then again, remember we need to apply the product rule here. So I have y prime over y equal to the derivative of x to the 1/2 times natural log of x plus x to the 1/2 times the derivative of natural log of x. Okay. Then I have y prime is y times 1/2 x to the negative 1/2 natural log of x plus x to the 1/2 times 1 over x then. And now I have y prime is equal to, okay, so y is x raised to the power of x. And then now, So I have natural log of x over 2 times square root of x, okay, plus this one is 1 over square root of x then. Okay. Then I multiply the second term by 2 over 2, so we could combine these two together. So I will have y prime is x squared of x, and I have natural log of x plus 2 over 2 times square root of x. Okay. Yes. Okay. After we find y prime, then my next step, okay, I would like to find the horizontal tangent line now. Okay. Then I would like to set y prime equal to 0. Okay. So I will have x squared of x equal to 0, or natural log of x plus 2 divided by 2 times square root of x equal to 0. Okay. And now we know that to this one right here is actually is impossible to have the result. The reason is because the domain is only from 0 to infinity, right? It's never ever equal to 0. So therefore, to this one, we have no solutions to this one. Okay, then let's see how we solve this then. So now we could multiply both sides by 2 square root of x. Okay. Then I will have natural log of x plus 2 equal to 0. Okay. Then if I solve it, then I will have natural log of x equal to -2. Okay. And of course, in this case, we could have x is e to the -2 then. Right. Okay, so meaning in this case, yes, the graph has a horizontal tangent line at x equal to e to the -2, right? Now, even though the problem actually didn't require me to actually to sketch the graph, but since I have the informations, okay, that I have a horizontal tangent line at x equal to e to the -2, then maybe we could actually try to sketch the function then, okay? Okay, then to this one, okay, let's see how to actually graph this function, because this is again one of the technique or thing that Cal students should know. Okay. Then first of all, we know the critical numbers. Okay. Remember how do we find critical numbers? Is actually we could actually either set y prime equal to 0 or y prime is undefined, right? Okay. Or does not exist. Then in this case, we know that for y prime equal to 0, x equal to e to the negative 2, okay? So meaning this one will be my critical numbers, okay? And then to this one, for my y prime, if this is my critical numbers, okay? Then again, the domain of this function right here is actually from 0, so we could actually start with 0, okay? And then now, let us try to test, right? The function y prime now, okay? So how about if we use the number e to the negative 3, okay? Which is smaller than e to the negative 2, but bigger than 0, okay? To test, okay? So I have y prime at e to the negative 3, which is equal to e to the negative 3 raised to the power of e to the negative 3. And then I have natural log of e to the negative 3 plus 2 over 2 times square root of e to the negative 3. Okay. Okay. Then now let's try to analyze. We know that e to the negative 3 is a positive. Square root of e to the negative 3 is a positive. So meaning this one right here is giving me positive. Okay. And then e to the natural log of e to the negative 3. This one is actually I have negative 3. So negative 3 plus 2 is negative over 2 times this is positive. Okay. So it's turned out that if I multiply them, I have positive times negative divided by positive. So this is a negative right here. Okay. And how about to this side right here, I evaluate maybe the test point that I have is I'm using e to the power of 0. Okay. Then y prime e to the power of 0. Then now that means it's 1, right? So I will have 1 raised to the power of square 1, and then here. So I will have natural log of 1 plus 2 over 2 times 1, okay? So then you will see that here, it's turned out that I'm going to have positive. This is positive, this is positive, this is positive, okay? So this one is positive, okay? So what do we know about this function y here? Okay, so based on these functions, based on the y prime, then we know that the function basically is decreasing from 0 to e to the negative 2, and then increasing from e to the negative 2 to infinity then, okay? Then, of course, right now, we should be able to sketch the function now. So this is x, this is y, this is 0 here. Then I have e to the negative 2. Then again, to this one, we know that in this case, okay, if we take the limit as x approach 0 from the right-hand side of x square root of x, okay, then you will see that the answer that I have is really close to 1, okay. Okay, so therefore, again, we start with 1. And now what we do is we could sketch the functions, and then it's not a straight line. So we will have a local minimum at e to the negative 2, and then the function will go straight up, okay? And of course, to this point, it will be e to the negative 2, comma e to the -2 raised to the power of square root of e to the -2. Okay. Okay, so then again, we will have a local minimum here. Okay, so then we are done with this section now. Okay, thank you.